Greetings to all viewers. This is Professor Ankit Singh. We'll now move to the next type of problem or numerical, which is asked from traffic engineering. Okay. So from traffic engineering, we can expect problems on spot speeds. So there are two different types of problems. I'll go through them. The question is as follows. The table below gives the consolidated data of spot speed studies on a section of road. Determine the most preferred speed at which maximum proportion of vehicles travel. Okay. So there is a data given here. There is a table given in which we have the speed range in column 1 and number of speed observations in column 2. Okay. So this is nothing but the frequency of vehicles which are moving at this speed ranges. Okay. So from 0 to 10 kmph speed, there is 0 number of vehicles in our sample. Okay. From 10 to 20 there are 11. From 20 to 30 there are 30 vehicles. Okay. Similarly, for all these different speeds there are different number of vehicles moving at these speeds. Okay. Well, the question asks us to find out what is the most preferred speed. Okay. So just having a look at this data, you can see that the maximum frequency is for 40 to 50. Okay. It is 233 because 233 vehicles are moving in this speed. So our answer should be near about 40 to 50. Okay. So now let us move ahead with this solution. Now using the data from the spot speed studies, frequency distribution table of spot speeds is prepared. Okay. So here we have this data. Speed range, it is given in the question 0 to 10, 10 to 20 up to 80 to 90. From this you can write down the mean speed. Okay. So for 0 to 10, mean speed would be 5 kmph. Okay, it is nothing but the average. 0 plus 10 divided by 2, it is 5. Next for 10 to 20, it would be 15. 10 plus 20 divided by 2, it is 15. Similarly, you can do for all these speeds 15, 25, 35, 45 and so on up to 85. Okay, this is the mean speeds. Now the frequency, it is given in the question. Okay. So here are the frequencies. Okay. What we need to form is an extra column, that is percentage frequency. Okay. So for this column we need the total sum. Okay, what we do is we sum up all the values of frequency. Total is 687. Now you need percentage frequency. So how will you get these values? The numerator will be this value divided by the total into 100. Okay. So 0 divided by 687 into 100 is nothing but 0 itself. 11 divided by 687 into 100 is 1.6. 30 divided by 687 into 100 is 4.4. Okay. Similarly, you need to do it for all these. You will get these values. Okay. So for the check for this is for your correctness is or your accuracy of work. If you add up all these values, you should get 100. Okay. Since this is a percentage, so the total should be 100. Okay. So once you have obtained these values, now you need to plot a graph in order to find out what is the most preferred speed or the modal speed. Okay. Now using the above values, plot a graph with mean speed on x-axis and percentage frequency on y-axis. Okay. So along x-axis we have speed in kmph, that is the mean speed, and along y-axis we have frequency in percentage frequency. Okay. So we need to plot between column 2 and column 4. Okay. You can keep the scale as per your requirements, as per the size of the sheet. Okay. Here I have adopted a scale of 1 unit along x-axis is equal to 10 kmph and along y-axis 1 unit is equal to 5%. Okay. And the difference is 5, 10, 15, etc. Okay. So now you can plot these points. So for 5 along x, y is 0. So 5 here and y 0. So for 15 it is 1.6. So 15 1.6 is somewhere here. 25 it is 4.4 here. Okay, you can see this X marks. Okay, these are the points. So once you plot the points, then you need to join these points with a freehand curve. Okay, and once you have joined these points with a freehand curve, you will get this bell-shaped curve. Okay, now in this curve you need to find out which is the uppermost point. Okay, so this here is the uppermost point. So from this point you need to draw up a perpendicular downwards. Okay, it will intersect the x-axis at a point. Okay, and you can read this speed. Now what is the speed? It is greater than 50 and less than 60 and somewhere near about 52. Okay, so the modal speed is 52 kmph, and this is nothing but the most preferred speed. Okay, so we'll now move to the next question. The spot speed studies were carried out at a certain stretch of a highway with mixed traffic flow, and the consolidated data collected are given below. Okay, so the data is similar as such of the previous problem. Here also we have speed ranges and we have number of vehicles observed or the frequency values. Okay, so what do we need to determine here? Determine the upper and lower values or speed limits for installing speed regulation signs at this road stretch, and second, the design speed for check of geometric design elements of the highway. Okay, so now we need to find out the upper and lower values of the speed. Okay, so we need to provide some speed limits for any vehicle operation on roads. Okay, there should be a lower speed limit and a upper speed limit. So we need to find out what the values of those are, and also we need to find out the design speed for that road. Okay, so in the solution, here we have the speed ranges, so we write them down similarly. Now we can write down the mid speed. Okay, as shown in the previous problem, it is nothing but the average between this range. So 0 plus 10 divided by 2 is 5, 10 plus 20 divided by 2 is 15. Similarly you can do it. Okay, then you have the frequency which is given in the question itself, so you note it down over here. Now we need to find out the frequency percentage. For that, what do? We do the summation of this table. We got 850. So for first value it is 12 divided by 850 into 100. It will give us 1.41. Second is 18 divided by 850 into 100 is 2.12. Okay. Third is 68 divided by 850 into 100 is 8. So similarly you do it for all these values and you get the percentage frequency. Now whenever you are asked the upper lower values of speed limits and also the design speed, then you need to find out the cumulative frequency. Okay, so cumulative frequency percentage this is. So here what you need to do, you have this percentage frequency values, you just need to take out the cumulative values. So when you find out the cumulative values, the first value will remain the same. How will you get the second value? It is nothing but 1.41 plus 2.12, which is 3.53. Now again 3.53 plus 8 is 11.53. Then 11.53 plus 10.47 is 22. So similarly you can do it for all of this. Here the check is you should get 100 as the last value. Okay. Now once you have this table, now we need to plot a graph. Now using the values, plot a graph with speed in kmph along the x-axis. So along x-axis it's the same speed again, and cumulative frequency percentage along the y-axis. Okay, so unlike in the previous problem, here you need to plot cumulative frequency percentage. In the previous problem it was only frequency percentage. Now you need to plot cumulative frequency percentage. Okay. So here the scale that I've used is along x-axis 1 unit is equal to 10, and along y-axis also 1 unit equal to 10. Now you can plot the points between mid speed and the cumulative frequency percentage. Okay, so for 5 it is 1.41, so for 5 it is 1.41, for 15 it is 3.53, somewhere here. Okay, then for 25 it is 11.53 here. So these X marked points are the points, okay, that were plotted. Now once you are done plotting the points, you need to join the points with a smooth hand curve. Okay, now you need to find out the upper and lower lead speed limits. So the lower speed limit is given by the 15 percentile. Okay, so 15% is the lower speed limit. So what you need to do is, along y-axis you need to take the point 15 over here and extend a horizontal from this point. Okay, it will intersect the curve at a point. From there you need to drop a perpendicular to the bottom, and you have a speed value over here which is v1. This is nothing but the lower speed limit, and here as you can read it is something around 27 kmph. Now for upper speed limit we take 85%. Okay, so you need to locate 85 here, then take a horizontal, cut the curve at this point, then drop a perpendicular. It will intersect the x-axis at this point. This is nothing but v2, and as you can read here, okay, it is something around 58. So this is nothing but the v2 is the upper speed limit, and the value is something around 58 kmph. Okay, so now you have the lower speed limit and the upper speed limit. What you need now is the design speed. For design speed what we take is 98%. Okay, so 98% you locate it here. You take a horizontal towards the curve, cut the curve at a point, then you need to drop a perpendicular. It will intersect the x-axis at this point. Read this value, it is something around 78 kmph. Okay, so v3 is nothing but the design speed, and it is something around 78 kmph. Okay, so this is how you find out the lower speed limit, upper speed limit, and the design speed. Okay, this is all for this second problem also. Thank you.